So this is sort of the second part of sig figs, and this is really about using your calculator. We'll still keep practicing applying that convention of sig figs, but this time we're going to talk about scientific notation and sig figs. And so a lot of this is calculator work. If you have difficulties with your calculator, you might find this video almost useless. So in which case, please feel free to ask. Talk to me about how you run your calculator, because there's quite a diversity of calculators out there, and each one seems to have its own little quirks. So I can't really make a video that works for all, but I will do my best. So in science, like we deal with really big numbers and really small numbers, you're going to get stuck applying the significant figures convention to numbers in sig figs, or sorry, in scientific notation. And so also it's important to know how to run your calculator and input numbers in scientific notation. So in these ones, if I take a look, this number here has 3 sig figs and this one has 4, right? Everything in front of the times 10 business counts as significant. So my answer would have 3 sig figs in it. And so this is all about calculator use. So in inputting these values, typically what you do is enter 6.02, and then you have a button on your calculator. On some calculators, it's an EE or EXP. On some calculators, it's a big button down the bottom that really looks like this. It's times 10 to the X. You do not want to use buttons that are 10x. That's going to work most of the time, but not all the time. The other thing is that you'll notice I'm not putting in times and then 10. We're not doing it like that. There is a button that replaces, there's a button that puts this in to your calculator. So after that, if we're inputting this number that we're starting with, then you just put in 23. That's the number of the exponent. So that would input this number. If we want to multiply it, again, the series of buttons I'm putting in boxes over here, you want to multiply it by the other digit in scientific notation. So you'd punch in 4.155, and then the button that works on your calculator that does this scientific notation for you, whatever it is, and then the exponent that you see. And then you can hit equals. Now, this series of buttons might not work for all of you, but give it a try. What you should get is this number, but it might not look like that on your display. So check your calculator. Use this as a way to check your calculator to see that it's working. And if it isn't, then let me know. If it is, then you can move on and try these numbers down the bottom. And so some of them have some pitfalls in them. I'm going to go ahead and put the answers rounded for sig figs up here. Oh, I just found a mistake in my key. So this first one works out to that on my calculator, but I'd want to round it to 2 sig figs. The answer key is 3. Sorry about that. If you want to put in a negative exponent, you just hit the plus minus button before you put in your exponent. Again, I'll just put these answers up with a couple little handy hints as I go. Rounding to the number of sig figs that's going to limit my answer. Oops. And these bottom ones have a number of ways to get to the right answer. So I'll put the answers up and you can double check them. And then I'll give you a couple handy hints that if you go wrong, what might be going wrong for you. So if you want to pause and catch up there, that would be good. These ones down here at the bottom, I have a way of doing them that seems to work all the time. Now, you can do it. You can calculate this and then divide the top by the bottom, or you can calculate this and then divide it by this all calculated. You can do it in multiple steps. I like thinking about, especially for this one, if it's on the top, multiply, and if it's on the bottom, divide. And so with this sort of way of thinking about it, I can input this question in one fell swoop. So I would punch in 286 times this 7.07 times 10 to the negative 8 divided by this number and divided by that number. And in that way, I don't have to worry about the pesky brackets, and I should get this answer. And again, like I've said other times, if you can get to the right answer, I am happy for you, and you don't have to do it my way. If you have trouble, some of these handy hints can be useful. They give you some strategies that make things a little bit easier for you. So on to the next part is a little bit of an optional thing. If you've done math, especially math 50 lately, you're going to have experienced some exponent rules or exponent laws. And so these ones can be done without a calculator using your knowledge of exponent laws. The other thing, if you don't want to just not use a calculator, because honestly, why would you? They're good for checking your answer. They're good for determining if it's correct or logical. So you can check your answer like these. Sometimes I forget to put the negative in on an exponent, right? And so with these ones, what you can see is that you have a base 10. And when you multiply common bases in math, you know that you add the exponents. So this would be 4 times 2, so 8 times 10. And if I wanted to show my work, I'm adding 4 to 5, right? 8 times 10 to the 9. If you have not done math lately, or you're like, what are you talking about, Marianne, with these exponent laws? Just do these ones on your calculator. That's the answer that you should get. So same one over here, you can just do this on your calculator as another place to practice, or you can do it with exponent laws. So either way, I'm going to put the answer here. And if you're not doing it with exponent laws as sort of this optional thing, right, then this is probably what you're thinking. You multiply the 6.3 and the 2, and then you're adding the exponents on there. This is what you would get by applying your exponent laws, but it is equivalent to this value that your calculator would probably get. You can have it not in standard scientific notation, but in scientific notation. So fixing it, we're moving the decimal over one more, and this would be it in standard scientific notation. The last little bit, not very often done, just as a reminder that we had a different convention when we were adding and subtracting things and representing them with the correct number of sig figs, because we don't want to make our answer look better than the data that's going into getting that answer. In these ones, I find it's easiest to write them out and see it visually or graphically to determine where you should do your answer for sig figs. So this first one, writing it out in standard notation, and writing this one out in standard notation, and then adding them together. I usually do this on a calculator. I do this thing of figuring out where does my certainty end, and drawing a line down at that place value allows me to figure out where I'm rounding to. And so my answer here would be 0.0507. If it's given to you in scientific notation, sometimes it's good to write it in scientific notation, but honestly, I'm not all that particular. They are equivalent. If I wrote this in scientific notation, it would be 5.07 times 10 to the negative 2. So either one of those is fine as an answer. And if you want the practice of going back and forth, this is a good place to do it. Or sometimes you have to go back and forth to check your answer on my answer key. So these last ones, I'm going to just show my work. I think it's worth writing them out so you can see where the certainty ends. I tend to add them on calculators anyway. And then this act of figuring out where the certainty ends. allows me to see how I'm supposed to round this to get my answer. You always want to preserve the value. Can't just drop all those zeros. And you can write it in standard or scientific notation. Whoops, I did that wrong. I counted. I should just copy my answers always. Okay, last one. I always forget that I've put this one in here. So much work. When I take and draw this line and then round, take a look at what happens. Come right back to where I started. And I always like ending with that one because it brings me back to the whole point of sig figs. So this is equivalent to me driving from here to Ontario. This amount of a distance in that big of a trip is insignificant, right? That makes sense on a logical level. And so now that we've rolled it into this academic convention and it gets real mathy and real schooly like, you know, it does make sense. This doesn't really matter in the grand scheme of things. And so, you know, following our academic conventions, we rule this as being insignificant, which you would honestly know intuitively if you were driving 9,000 kilometers, right? Yeah. Anyway, that's the end of us for sig figs. It's probably the toughest bit in this chapter 2.